So one of the other topics that often comes up as we're starting to consider microservices architectures is how we deal with data. It's one of the most important topics. You can't forget about it. One of the premises of microservices is that we focus on bounded context, and we break the data model up into separate domains that are governed and owned by the services that run them. But ultimately we start to run into problems that we've solved other ways where those solutions don't apply anymore. How do we handle transactions? How do we handle questions that cross API boundaries? As it turns out, there are several patterns that we consider and other ideas that we can look at that can help to inform us. One of the first ones we'll look at is the CAP theorem and start to understand, how we're able to make decisions around consistency and availability of distributed systems composed of microservices, and start to think about maybe moving more towards eventual consistency based systems and moving away from things like transactions and distributed transactions. We'll also look at CQRS, or command query responsibility separation, and how having different views of a data model can help us to solve some complicated problems. We'll look at event sourcing, or using sort of a fact-based append-only data style approach that allows us to build very resilient data architectures that can recover because we can always recreate the current state from past history rather than having an update in place architecture, and ultimately pouring a lot of that into this idea of a lambda architecture that was popularized by Nathan Mars in his book on big data.